3.5 Implicit Differentiation. So before we get into implicit differentiation, we need to go over the difference between implicit functions versus explicit functions. You're probably more familiar with explicit functions, where the equation is y by itself set equal to a function in terms of x. Okay, that's an implicit form. Implicit function is when x and y are on the same side of the equation, or basically any equation where y isn't solved for, where it's not y not equals something. Alright, so that's the difference there. Finding the derivative of implicit functions are no problem, right? So if I ask you to find the derivative of this is just an explicit function here. We could think of this as being the derivative of x to the negative first all over, with respect to x. So this would be the power rule, negative 1 x to the negative second, or negative x to the negative second. That would be fine, right? Okay, remember the derivative of y with respect to x. This is the derivative of y with respect to x. Okay, so notice this equation here. This would be implicit because it's not solved for y. We could try to solve for y, but it would be more difficult than what it's worth. Instead, it's going to be easier just to go ahead and do implicit differentiation. So let me show you what I mean. You're taking the derivative of each one of these with respect to x. Okay? So this one is with respect to x. This one is not with respect to x. That's with respect to y. Same with this one. And this one's a constant. So if it's a constant, you can assume that it is with respect to x or whichever variable is there. Okay, so if we took the derivative here all the way through, this would be 2x to the first, nothing new there. This one here, this would be negative 6y squared, and then what you would do here, you would multiply this by dy dx. Okay, because this one you're taking the derivative of y with respect to x, so you need to multiply that by that. Okay, where this one was the derivative of x with respect to x, so technically you can look at it this way, the derivative of x with respect to x, but that's 1, so we don't really write that there. This next one is going to be plus 4. Again, you need to do dy dx. Okay, because again, you're taking the derivative of y, okay, a function in terms of y with respect to x, equals the derivative of constant is 0. So we have that. And now we're going to solve for dy dx to see what the derivative of y is with respect to x. So to do that, I'm going to subtract 2x from both sides. I'll get negative 6y squared dy dx plus 4 dy dx equals negative 2x. Then I will factor out dy dx, leaving me with negative 6y squared plus 4 equals negative 2x. And then I could divide both sides by this negative 6y squared plus 4. So, dy dx is equal to negative 2x all over negative 6y squared plus 4. And then if you look here, I can divide each of these by negative 2, resulting in x over 3y squared minus 2. So that would be the final answer. So let's try an example here. Find dy dx given this equation. Okay, so again, this equation is implicit because y is not solved for. So we're going to take the derivative of this whole thing with respect to x. So you're going to do this. Okay, and go through here and do implicit differentiation. So here, implicit differentiation will apply because this is not with respect to x, it's with respect to y. So I'm going to do 3y squared, and the only difference is now you have to multiply this by dy dx. This would be very similar, so this would be plus 2y dy dx. This one as well, so this would be minus 5 dy dx. This one is with respect to x, so you just take the derivative, negative 2x, equals a constant. Constant, we can assume that that is with respect to x, so we'll say that to 0. And now we just have to solve for dy dx. So I'm going to add 2x to both sides. And at the same time here, I'm going to factor out dy dx. So that would leave me with 3y squared plus 2y minus 5 equals 2x. Then I'm going to divide both sides by this guy here. So dy dx equals 2x all over 3y squared plus 2y minus 5. Okay, so that would be solving for dy dx. But this problem, they wanted you to go the extra mile. They wanted you to find the equation of the line given the point 2, 0. So if we want to find the slope of the tangent line, okay, for dy dx, when at 2, 0, x would be 2, so we'll do 2 times 2, and y would be 0. So this is going to end up being negative 4/5. Okay, so we have the slope, and then if we use y equals mx plus b, y is 0. The slope is negative 5/4. 2 is x. 0 equals negative 8/5 plus b. Add 8/5 to both sides. So 8/5 is b. So y equals negative 4/5 x plus 8/5. That would be the equation of the tangent line.